Alright, well we just got our RevB PCB in. Came a couple days early, so that's nice. And we're going to hop in and see what she looks like. The box is larger this time because now we have a stencil so that we don't have to hand solder everything. Odd. This is a handmade box here. It doesn't have to be formal. It's just been cut down, I guess. There's a box in the box. Cool. So, we've got the PCB proper. We'll set that aside for dramatic suspense. This is our stencil, we'll just look at it real quick. So if you're not familiar with stencil, it's how you apply the solder paste for all your SMT components. So it's just got little holes in it. And well, that looks about right. It really is amazing when you look at it like this. There's how few surface components there are. I mean, there's like 600 of them, but like, it's not that many compared to the size of the PCB. Cool, that looks good. So let's look at the PCB. Ah, that looks great. I like it already. So I ordered 10 of these. And I'll build 10, and we've got 5 beta testers, and that'll give me a couple units for myself, a few to play around with. Oops, air fins. They did a bang of job on the gold this time. Here, let's look at the old PCB. Just shiny. I think they plated the gold even thicker than they normally do. But yeah, same mechanical dimensions. This is the RevA, and that is our RevB. They look identical, but there are a lot of changes. Learned a lot. So yeah, it looks good. We'll get it built up. I wanted to make sure these connectors fit. So here is, there's our new ribbon connector, and from that we will plug in our ribbon cables. So here's that's the 18S1, and here is the 12S1, and there will just be ribbon cables now that plug in like this, and then they'll go to the OEM connector on the lithium battery, and those fit just fine. Yeah, looks good. I like it. They've outdone themselves. I always love it. This is Seed Studio. I always love them. They do exceptional work, and this time they've just really hit it out of the ballpark. Oh, cool! My Tetris pieces came in well too. I was curious what these were going to look like. So I had some extra room, so I put some Tetris pieces on there. Looks great. If you shine the light through the back, which I don't have light in here right now, but the back has some pieces on it as well, so all the pieces should look different eventually. That's fun. Yeah, the ground planes came in great. I got some nice via studding on the to keep the ISO-SPI signal nice and noise free. We had some real large noise last time because we were coming right by the switching power supply. Of course, the switching power supply itself had some major issues, so we've fixed those now. We've got parts underneath our power supply. This is our high voltage safety isolation feedback stuff here. So this is the only part of the PCB that is not galvanically isolated that is high voltage, and it's two series capacitors. We put two of them in series so that if one fails, the other one is full rated voltage as well. If the other one fails, we've got ground chassis that we'd be shorting to, and the MCM would be catching that with its 300K leakage test, and if it were to catch that, it basically opens the contactor. So anyway, yeah, it looks great. Of course, we need to build it to make sure it works great as well, but yeah, it looks good. I'm happy with it so far. Now it's just all the tiers ahead of finding all the things that don't work about it, which hopefully isn't a whole lot. We'll see. So time to go to Austin. I'll probably leave tomorrow morning, and yeah, see what happens. And we got the open source hardware logo. Last time I KiCad deleted it, so here it is this time. This is not actually a piece on the schematic, so if you pull in the netlist file in the layout and you tell it to delete parts that don't have pads, or delete parts that are not in the schematic, it will delete the open source logo. So anyway, this time we made sure it was under there. So cool, very good. I'm excited. It's excited to get these beta units out.